Welcome to today's KM World webinar, brought to you by Fluid Topics and Sinequa. I'm Mary D. Ojala, Editor-in-Chief at KM World Magazine, and I will be the moderator for today's broadcast. Our presentation today is titled The Rise of GenAI Agents and AI-Powered Search. Now, before we get started, I want to explain how you can be a part of this broadcast. There will be a question and answer session, so if you have a question during the presentation, just type it into the question box provided and click on the submit button. We will try to get to as many questions as possible, but if your question has not been answered during the show, you will receive an email response to it within a few days. And now to introduce our speakers for today. Fabrice Lacroix, CEO and founder, Fluid Topics; Jim Marlowe, sales engineer, Sinequa. Now, before I hand this over to Jim, I had a few introductory comments to make based on this slide from Sinequa. I've been involved with search for a long, long time, and I will say that although this slide says it's still early, it's both early and late all at the same time. We've had chatbots, we've had transformer technology. What we haven't had is the incredible impetus that AI has brought to the picture. So when OpenAI introduced its chatbot back in November 2022, which, it wasn't that long ago, but it certainly feels like it was centuries ago. And we've now got so many developments going on with GPT, generative pre-trained transformers, with RAG, retrieval augmented generation, with AI assistance. Didn't you always want somebody just to do things for you that you didn't want to do yourself? Yeah, now we have AI assistance. And then moving on to agentic technology. So we've moved from how questions get answered, where the data is coming from, external, internal, to predefined, to being able to have AI agents that basically have some autonomy and do some things literally for you. So to talk a little bit more about how the AI agents need knowledge, focus, personalization, tools, and governance, let me turn the proceedings here over to Jim. Go ahead.
Thanks, Mary D. I appreciate the introduction there. So we're going to dive in and talk a little bit more about how we're going to move from AI just as something like a chatbot into a true AI agent and how to do it quickly and safely. So you can think of an LLM, large language model like ChatGPT or Claude or something like that, as an intern. I was explaining this to my mother the other day. I'm like, think of it as an intern. They're freshly hired. They work hard. They don't have any experience. They don't know how a lot of things work. They can answer general questions, possibly quite quickly and thoroughly if you've got the intern who's good at, well, used to be good at Google, but they don't know your business. And to illustrate this, I asked ChatGPT how to set up a Sinequa server. And this is the instructions that I got that are on the right-hand side of this slide. Please, please, please don't use this to set up your Sinequa server because it is completely wrong. First two steps are broadly right and useless. And then the details that started below, and I think there were 8 or 10 of these high-level ones that I just gave you one of, are completely wrong. So we run on Windows. We don't require a JDK. We don't require a database for our metadata, just to pick on those 3 right there. But it was really fast. Came back to me quickly. That's great, right? It's friendly. All right, so let's move on a little bit. The way we like to think of this is there's 5 strategies for doing agentic AI right. And there's 5 key steps in this process. And we'll talk about them over the next few slides. But at a high level, they're inform, focus, personalize, equip, and govern. Those are the 5 things you need to be thinking about how you're going to do. So the first one of those is inform. And this means informing your agent, providing it additional data, providing that information that, for example, tells it how to set up a Sinequa server, giving it access to critical data that it can use to answer questions and provide real information to you. So with Sinequa, you get connections to about 200 different data sources. So these are all things that, say, ChatGPT doesn't have access to. And that's both structured and unstructured data. So documents, things living in databases, things coming off of REST APIs, anything like that. And the ability to work with about 350 different types of documents out of the box. You also get multimodal processing, so you can work with not just text, but also images, audio, video, things like that. And the full content of documents. So if you have a 1,000-page PDF that's out there, that whole thing is available to the agent to ask intelligent questions of, including all of its metadata. And then we can associate all of this with all of your own internal taxonomies, synonyms, project names, part IDs, anything else that's very, very, very specific to your particular company. So you can start to actually get real answers from that agent. So step one, inform. Step two is to provide focus. So the agent isn't just looking at all of the knowledge in general, but very, very specific knowledge, and giving the agent the ability to retrieve a specific answer or data for a specific answer to a question. What you're really wanting to do is get to the point of having on-topic, high-value, and informed results. They need to be based on your corporate knowledge, and this is going to provide much more accuracy, much lower hallucinations, and it's going to be lower cost. So doing this is something called hybrid unified retrieval. So it's intelligently blending results from different types of data that's coming back. These are vector data, so semantic matching. This is a way to store information that can be used by an AI. Keywords, so precise matching, this is a thing you're familiar with, although it's much more advanced in a platform like Sinequa. Graph databases, so storing data that has relationships between different pieces of information and other information about those relationships. Text to SQL, so structured data, things coming out of databases, like I mentioned, REST APIs, stuff like that. And then multimodal data, so going beyond that into video, audio, that sort of information, embedded images inside documents. So how do you handle this? Well, what you actually need is something called the RAG pipeline. And the first thing to remember is not all RAG is created equal. And Mary D mentioned this, retrieval augmented generation. So this is the AI agent going out and contacting something else and asking for additional information. If you feed every query into the model without thinking, you end up with generic and sometimes really brittle results. What we want to do is inject personalization and intelligence at every stage of the workflow. So the process is going to look something like this in detail. The query stage, the agent starts by trying to understand intent. And you will see this show up even in something like ChatGPT, definitely in Sinequa, as the thinking stage. You'll see it's like thinking, and it's starting to work its way through the list of potential things that it needs to look at. This is trying to figure out, are they asking for definition, links to documentation, analysis of reports? What's the person really looking for? And this can fire off multiple subqueries. Each of them can target a different slice of content or maybe a source. And the agent will eventually take all of those queries, refine the keywords, acronyms, taxonomy, tags, and choose which sources it needs to get the actual information from. And then it will filter out all of the low quality or stale data, so all of the older documents. So step one, the next one is the retrieval component. And this is where the agent starts to build tailored prompts to search for specific data. It's also going to fold in what it knows about a particular user. So your user information, your profile, past interactions, any preferences that you have, even long-term memory of earlier chats or context from the current chat that you're having. After that, we come to the real meat of RAG, which is the LLM generating an answer from all of this information that it's pulled back. It's going to add citations and references and make sure that they're actually valid, so you can trace facts back to a vetted source. It will also control content and style to make things look the way you or your company wants them to. And that might be length, it might be tone, it might be layout. There might be a template for providing answers in play. It's going to feel consistent with your brand and your users' expectations. And then finally, it's going to package all of that up into a response, and it'll be in the format you need. And it might be a conversational snippet. It might be a link to some piece of information. It could be a formatted document, tables, diagrams, maybe even a full analysis or a report on something. This is all going to be packaged up and delivered back to the user. So in short, a robust RAG pipeline isn't just retrieve and generate. It's a 4-step personalized journey that maximizes relevance. It's going to provide trusted, usable information back to the user. And this is how you move from, say, a naive or an intern level LLM to an advanced RAG. All right, so let's move on. There's some additional things that might be handy for your AI agent, and tools are one of those things. So if we think about this, agents are powered by LLMs. And there's some things they do really, really well, and there's some things that they do poorly. They can answer questions, certainly. Sometimes they're not good at math. Sometimes they they can't pull specific information they need. And they also certainly can't do things like file bug reports or send emails or generate reports on a schedule, anything like that. So what you really want is an agent that's actually able to take action. So what your agent needs is tools. And this is where something called MCP, or Model Context Protocol, comes into play. And I love how Mary D said, this is really old. It goes back to 22. This is a very, very new thing that has mostly started appearing this year. And this is how your agent is able to do real work for you. And it's, the submitting of the bug reports, the picking up of information, the talking to calendars, running reports automatically, looking for problems in systems. MCP provides that framework to give your agents access to the appropriate tools and explanations of how to use those tools. So the agent can talk to an MCP server, and the server will say, here's what I have available for you, and here's how you actually make use of this information to do real work. And this can happen without actual huge amounts of coding that you would normally have had to do many, many years ago, say 2024. All right, so finally we get to the last part of this, and it's govern. And ultimately, you're not going to have one agent. You're not going to have 10. You're not even going to have 100 of them. You're going to have thousands. You're also going to have tens or hundreds of millions of documents. We see this every day with our customers. And thousands of users, or maybe even tens of thousands of users. And you have to actually figure out how to manage all of this. And you have to figure out, most importantly, how to keep everything safe. So what you really need is an orchestration platform when you're working at this sort of scale, and it's something like Sinequa. It's what we do. And this allows you to manage and control your agents and the data that they have access to. Most importantly, it's providing the end users with only information based on data that they can actually see. So respecting your corporate security, controlling who can see what information. So you're really thinking about security, observability, traceability, monitoring, versioning, usage tracking, that sort of thing. It's all going to be handled in one place. So having gone through your 5 steps, congratulations, your AI agents are no longer interns, they're now experts. And it happened very, very, very quickly. So they're informed about your enterprise knowledge, and this could be anywhere. This could be SharePoint, which is one of the more common platforms we see, but it can be all sorts of other things internally or externally. So REST APIs, external data sources, files coming in, can be any one of those things, or all of them at once. They're focused, so they can do hybrid retrieval of the information that matters and the highest value information. They're personalized, so they know who they're working with in the way of a user, what the user's choices are, how they like to interact. They also know how the company wants things to be responded to, maybe what acronyms to use, that sort of thing. They're equipped with tools to do their jobs, so they can reach out and work with other systems to pull information in. And then they're governed, managed, and scalable. So they're keeping your data secure. You know who's doing what, when, and where, including with the agents. And as you add more and more users and more documents, they'll scale. So what's this all look like? Now that you have expert agents, how do you manage them or govern them? Well, remember that's step 5. To do this, you need a platform, what we've been talking about. And it consists of 3 components, really. So the first one is the AI-powered search. And this is something Sinequa has been doing for years and years and years. The platform needs to securely ingest and process your content wherever it is and in whatever format it's in. And that includes, is it image, text, video, data streaming in from somewhere, and then make it available to your search agent with the right context, so wrapping the right metadata around it. You need to have the actual AI agents, so delivering those out there, and you need to be able to build ones that are enterprise ready, that are reliable and scalable, and they're fully integrated into your internal applications and ecosystem. So no going off and necessarily and finding another agent or working with another application. You can be working right from inside the tools that you would normally use. And finally, as we talked about, they need to be monitored and governed. So this is keeping control of who has access to the data, seeing what's actually going on, managing that, and then using it in real time to improve the tools that you're delivering out to your users. So let's take a look at this in action and see an example. And I'm going to start here with just a business question about using a cheaper material for the housing of a product and what the viable alternatives might be. So this is just an engineer. They have a question. They know that the base data to answer this question is in the company's own internal documents, but there's literally millions of those. And even with good keyword search, this could take some time to answer. So you can see that this is a multifaceted question. This is really the sort of thing where agentic RAG is going to be useful. So let's take a look at the actual process that's going to happen here. First step is the thinking process, the evaluate what the users ask for and extract the actual questions to be answered. Then there's the initial search, and this should be sounding a little bit familiar at this point. The agent's going to go out, pull back the information that it needs to see to at least start generating what it actually needs, the information about what it actually needs to retrieve at a more detailed level. And in this case, if you're using Sinequa, we're going to use our neural search functionality. So the agent may actually just write a question out as a sentence or two and send that into the Sinequa search engine and retrieve data that way. And it's going to be using in-domain knowledge to run, alternative queries, interpret jargon, find information from all the different sources. One of the things we frequently see with customers are they'll find sources they didn't know existed. They'll find that things have been answered 5 or 6 times, like questions have been answered or problems have been solved 5 or 6 times when they start using a tool like this. And there's 2 reasons for doing this particular stage. One of them is exactly what I just said. What if somebody's already solved the problem? We might as well just give that back to the user and say, here's your solution. It's tried, tested, approved. That's all you need to know. If not, then it needs to do a little bit more planning at this point to get additional information from internal sources. Next step is the planning and execution. In this particular example, although it's not always going to be like that, this is what the agent has done. So it's going to identify critical, things like critical material properties from existing documentation. It's going to look for alternatives that might be cheaper, that could still work, and that might include going through data sheets and test data, and maybe even assessing cost and availability depending on what systems are connected out there. It's going to query the procurement system for pricing and lead times of viable options. So this is, again, reaching out to another system with a tool. And then it's going to propose a viable solution and compare alternatives based on the properties, cost, and availability, highlighting pros and cons and trade-offs. So all of this is going to be based on both the initial search, the user's context, and all of the information that's been pulled back from a number of different tools, including Sinequa. And the end result of this is a comprehensive answer. It's created for the end user and includes the appropriate references. It gives a short answer, and in this particular case, then some more detailed assessments. And I've seen some of these run to several pages, plus all of the references as about what data was actually pulled back. All right, so I'm going to drop into a demo very quickly, and we're going to do about 3 minutes of demo. You're going to see your screen go black while I do this, so just bear with me for a second, and then we will be back online. Okay, you should see a demo screen. So we just walked through an example of how a text search would work in Sinequa, but I'd like to actually show you how this works in the live platform, and we're going to be using our multimodal agent, which is a little bit more sophisticated than just text search. So I'd like you to imagine for a moment that you're an engineer and you need to do a root cause analysis of a problem that you're unfamiliar with. You don't really know where to start. You're sure the information is somewhere in your systems, though it may not be in text form. So there might be a diagram or something that explains how to do this, but you're not quite sure where it is or what it's going to look like. And this is where the multimodal capabilities really shine. It's the ability to use non-text data to generate answers to questions. So this is the Sinequa user interface. It's going to look pretty familiar. If you've been using an LLM of any kind recently, this is the standard, there's a chat window here, there's a place to enter some text here, and then you're going to be interacting with the LLM as you go back and forth. So I actually have a question already pasted in here. I'm conducting root cause analysis, etc., and I'm going to hit send, and we're going to see this process start up. So I've asked my question. The agent's now working on the answer. The first thing you're going to see is the thought, and this is the agent figuring out what it actually needs to do. So this is not quite the same as the question that I've asked. And then you're going to see a query. Then you're going to see a query, and it's found 2 documents that have come back. Then you see here where it says multimodality. This is where it's going through the process of reviewing the results, digging through the actual information, and looking at the images and analyzing those too. And that's very important. So this is not just looking at text, it's also looking at images. And it's found 7 relevant pages out of a fairly large document. And then it's going to generate an answer. So let me take a quick look at this. So what's happened here is we've had an answer generated, and what it's done is it has made use of something here called a fishbone diagram. And this is a diagnostic tool that's frequently used to work your way through a problem on a specific thing to figure out what's going wrong. What's happened here is the multimodal agent has picked up this image and said, aha, this is a diagnostic program. I can use this to start working my way through and actually figure out what the problem is for my end user. So it's working its way through this process and then using the results of that analysis to provide this conclusion here. So what you're seeing here is also not just a list of documents. So which you might get back from a standard search, like a list of documents, maybe even a prioritized list of documents. And it's not even just an answer generated from text, but like I said, it's actually been made, the fishbone diagram has actually been made use of to produce an analysis of a problem and some recommendations for troubleshooting and mitigation. What's really interesting about this is how that's all been put together. And then we have all of the associated documents that are referenced in line so you can see where the actual answers came from. What you've seen really is agentic AI in action here. So it's informed, it's focused, it's personalized, it's equipped, and it's been governed. So this is only information that I, as this particular type of user, can see. And if you think about it, if an engineer had to do this all by themselves, even with good search, this is going to take some time to dig through and find. And this can be an immense amount of time saving. Even if the engineer needs to go through and validate all of this at the end, it's going to save them an immense amount of time digging through documentation and doing searches. And this is also touching all of the available data. So there may have been a solution back here, for example, this one, that actually explains how to solve the problem. So I'm going to go back to the slides now, and then I'm going to hand it over to Fabrice. So thank you for listening, and we'll be talking more as we get into the presentation.
Yes, thank you, Jim. Thank you for this presentation. So I think I agree with what you presented, Jim, on the tech aspect. And I think everything about AI, when it started 2 or 3 years ago, people thought that to achieve this sort of things, they would need to first train or fine-tune a model. Then people realized that that was not the way to go. And probably using generic models with RAG to feed those models with contextual knowledge on the fly was the best way to go. And then companies started to build chatbots or agents. And I'd like to look at this process from a more operational perspective, because how many companies today have succeeded in building agents and chatbots that work really? And most of the time, they are not yet at the agent level. They are still struggling. Most companies are still struggling building a decent chatbot that is relevant. And we do have lots of customers, being companies you'll see, that have embarked on this journey of the IT teams trying to build something, and most of them has failed. And we'd like to dig into this. Why do companies struggle and mostly fail at building those RAG pipelines? So for me, it boils down to 3 things for being successful with AI successfully applied at the enterprise level. So there's one key aspect for me, which is everything related to domain knowledge. One is, how do you master complex content? And then how do you move from RAG to agentic? And I think there's a big shift. There's something happening now that we should dig in a bit further. So first, I'd like to introduce this idea of domain knowledge, which definition from Wikipedia is that's knowledge specific to a discipline or a field in contrast to general knowledge. And if you look at what happens inside a company, you've got this department like HR, finance, production and manufacturing, product engineering, sales, customer service, customer support, field service. And each department has its own set of tools behind that. Like HR, they have the ERP, finance, they have these ERP systems, invoicing systems. If you go to product engineering, they got PLM, or if it's a software company, they got those development environments and then the right documentation, so and so forth. And if you go down to these field service related departments, they have help desk tools, field service management systems, all of those tools. And in each of those tools, you have a mix of both live data, which are the operating data that people use every day, mostly highly structured databases. And then you've got a bunch of content, which is more a bit of knowledge that goes with those data. And this is very, very segregated content, each in its own silos. And this is how it works today. And each department is in charge of its own tools, managing that separately. And what companies want to achieve at some point is the dream they have is like when they saw this AI thing coming, it's like, oh, can we do if that one chatbot that can reply to any question? Pretty much what you've demoed here is like, okay, engineering question, can you solve that? But that could be as well the same chatbot or super assistant that could augment any worker for any type of questions. It's like this dream of, Jarvis from Iron Man, helping and chatting with Tony Stark and solving any problem, replying to any question. And that's the dream of every company. Can we achieve that? And that's where companies have failed mostly. It's like trying to build this thing that does everything. And the reason why most companies have failed is like because they're trying to build something that's overarching something and mostly building something on top of domain knowledge without respecting the fact that those are domains, okay? And trying to pull down everything to a central place and consider that it's just general knowledge of the company. There's no general knowledge in the company. There is only domain knowledge. And each domain has its own complexity that needs to be mastered, respected, treated, and understood. And to give you an example, because we are specialized in one of those domains, I'd like to look precisely at everything around the product knowledge. It's like technical documentation, product information management, and all that. And it's very specific and it's very complex by nature. It's complex by nature because if you look at one product, then usually for one product, whatever it is, a software, hardware, whatever, there's a bunch of manuals, guides related to that one product, whether it's installation, servicing, troubleshooting, IFUs, instructions for use, SOPs, standard operating procedures, whatever. And then the thing is that this product usually has variants. It's like probably and versions and customization per customer, per territories, per language, per whatever. And means that usually that one product and that one set of documents, in fact, becomes 10 times, 200 times varianted to be specific to that version of the product, that variant of the product, the one for the Japanese market, the one version 2 for the French market or whatever. And then for that customer, because for that customer, you don't have this option, but these specific parts or add-ons to the product. And then you multiply by that languages and iterations on the document themselves. And for like an initial set of 10, 20 documents, you easily end up with 1,000 versions of the same document, slightly different. And the complexity here, when people ask a question to a chatbot or an agent, is making sure that you use the right piece of information that is applicable to that version of the product in that configuration that has been issued for that customer. And sometimes there's not even one manual that is applicable to many products. It's one per instance of a product. Okay, so there's a complexity here that is a lot of redundant information. It's not like you're trying to find the needle in the haystack. That's the opposite. The same information exists thousands of times, slightly different, but you have to make sure that you use the right piece of information for the right version of that product in the right configuration. And that's a huge complexity. The other thing that people have realized when trying to build chatbots or to try to apply AI to product information is that it's not just about replying to a question. It's not like we need a chatbot and the chatbot will replace everything. Because typically, if you look at complex procedures for maintenance, you may have wiring diagrams, 2D, 3D graphics, or if it's API documentation, the API doc itself is actionable. You can test it, like Swagger things. Or if it's a procedure that needs to be run step by step and in which you need to enter values to move to the next step, there's a lot of complexity. And you don't replace that with a chatbot that can just hand over 2 phrases. You need the entire procedure. It has been validated for security compliance, and you can't replace that procedure with something that is being rewritten by a chatbot, because you are at risk of changing or removing or adding some key element that would put the product at risk, the technician at risk, the users at risk. So that's interesting to see that and that's true for the product knowledge domain, but it's true as well in other domains in the company, that the chatbot is not something that's going to replace everything, or the agent is not something that's going to replace everything, because there's complexity. And most of the time, projects have failed because they have forgotten this complexity of content, or they have forgotten the fact that the chatbot is it's just one step in accessing knowledge and using that knowledge. So that's what we do at Fluid Topics. I can tell a lot about product knowledge and product information and technical documentation because that's exactly what we do. We are the leading product knowledge platform. Fluid Topics is a software stack that is able to ingest any type of content related to products and add a lot of AI to that to change the way people search, read, access, navigate technical documentation in a very optimal way. So that's how it works. In Fluid Topics are mostly 2 parts. One is the backend part, upstream, which is this capability that we have to ingest any type of content related to the products. And that's interesting as well because Jim was talking about connectors, but most of the time, platforms that are generic for generic knowledge tend to take the content and go down to the text, the least common denominator, as opposed to domain-specific platforms like Fluid Topics, where when we receive technical documentation, like in XML, with XML format, where the semantic of the content, the tags, that means something like this phrase is only valid for that version of the product, and that paragraph has this metadata that needs to be checked with that configuration, or necessitates the user to have that credential or that skill to be allowed to apply this procedure. All these things are inside the content. So technical documentation, product documentation is highly sophisticated, and that's where domain knowledge platforms like Fluid Topics are able to leverage these semantics that exist in the content to maintain the semantic and make sure that whatever you build on top with AI, the context, this semantic is kept and applied when people try to access and read the content. So that's the upstream part. So we have all those connectors and support all those very specific formats to maximize the semantics that exist. And the downstream part is about delivering content to any touch point. Most of the time, the the vast majority of the first use case is build specific documentation portals, but as well, you can dynamically feed help desk tools or do in-product help by delivering granular information in the UI of the product to help the customers, or that's for building chatbots. That's what we're talking about today. That's where we are. And then we add to that capabilities for users to engage with the content, bookmark, collaborate, or we do have live translation of contents, like if you have your content in English and then the field technician is, I don't know, in Poland or Germany, we can translate on the fly and render that content in German. So all these capabilities for transforming the delivery and the interactions with content. So that's what we do at Fluid Topics, and I really want to emphasize the fact that we are not dealing with any type of content in the company. We are focusing on the main knowledge, that is the product knowledge, and we help our customers, which are companies building sophisticated products, tech industries, transform the way they do customer support and field service operations. So typical customers are, like you see, are very different by nature. It could be software, hardware, manufacturing. So you see some of them here. It's like if you go, I don't know, to AMD, docs.amd.com, that's in fact a Fluid Topics powered platform. So that's the idea. Moving on. So yeah, the reason our customers choose Fluid Topics is really reinventing customer support, bringing self-service, field service operation, chatbot, agentic AI are use cases as well that they leverage from Fluid Topics. And back to this AI discussion of today, I think what's important here is that our customers have tried to build those chatbots. Mostly they have failed. And you see the customers we have, it's like big companies. They have a lot of resources, skilled people, and still most of them has failed when it comes to building chatbots on top of product documentation because of this redundancy of information. It doesn't work. You can achieve relevance, whatever you want to do, whether it's a chatbot or an agent, because of these needs of keeping the semantics, the metadata, building graphs, this granularity of content that are key to achieving good results. And I think that now that we understand that when you build a chatbot at the domain level with a domain-specific platform, you get better chance to achieve good results because the platform itself, like Fluid Topics, can leverage the knowledge it has of the understanding it has of the domain, like the structure, the semantics of the content. But the question is, how do you scale that at the enterprise level to build those systems that can reply to any question? And I think the old way of doing, the old way being, yes, like past centuries, last year, 6 months ago, most of the projects I've seen run by the IT departments were about dumping all the content in one place, like a data lake or something like that, pulling content from all repositories, and then trying to point an AI stack like a generic Microsoft Copilot thing to this S3 bucket or whatever where they have dumped everything. It's failing because, again, there's a lot of semantics. Everything goes down to flat text. There's a lack of context. As I say, when information is redundant, why should you use that paragraph instead of that one to reply to the question if you can't match that to the configuration of the device on the fly? And mostly as well, people realize that the data is out of sync because they just pull it. And by the time they pull the content, they put it in the repository, they index it, and they build something, the data has changed. The content has changed in the source system. And if you want to do something that is smart, you need to pull into live data, not dumped data, not something that you pull from the system. And that's where we enter this new age and the shift in the way AI is moving towards. It's everything is about MCP. I've never seen something that, even since 2 years, when we see how fast AI has moved, I think MCP is something that is moving even faster than the rest of AI. That tells you how fast it goes. And the paradigm is changing. now people understand that no one should dump the content from each different silos and platforms to build something centralized, but go the opposite way, which is fully agentic and MCP capable with MCP capable tools. And if you look at all the communication of those software vendors, from Salesforce to ServiceNow, Jira, HubSpot, Siemens, SAP, whatever, all those systems are now MCP capable. Fluid Topics is MCP capable, and which means that now agents can dynamically tap into domain knowledge, and each subsystem that is MCP enabled will be optimal because it will manage the semantics of the domain, managing live data. It's like if you have SAP and you query SAP or ServiceNow through the MCP protocol, you have access to real-time data and you can act on those data. So you don't need to dump anymore. You don't need to build massive systems that collect information, but it's more like the age now of, in a new age, new approach, which is about building central system, agentic system that each tap live through MCP into those silos that are now MCP enabled. And I think that's pretty much where we are today. And for me, we are entering a new age where most of the time we were looking at knowledge for something that would be consumed by humans. And that's probably 99% of content consumption from Fluid Topics. Product knowledge was searched and read by humans until now. And we're entering this new age where now the knowledge will be this new time where knowledge will be consumed by LLMs for this agentic system. There won't be any people behind those. At no moment in time will people read something. It's just LLM making decision and acting. Companies are going to rewrite their processes and workflows to make them fully autonomous, fully run by LLMs, and LLMs will pull dynamically into those silos, domains, for getting the information they read on the fly. So I think that's very interesting because we are going to see a big shift in the way knowledge should be managed and and by whom it's going to be consumed, meaning both humans and now LLMs as well. Those were my takes on the subject.
Okay, now, well, thanks to both of you. I will say that I am totally struck by two comments that I didn't know whether to phrase this as a rhetorical question or not, but Jim said he used the word old, and my question was, when did old become 2.5 years ago? And then Fabrice raised the ante on that one and said back in the past, and he was talking about last year. So we've sort of not just redefined a lot of what's going on with technology, but even how we think about time frames. And I think, I mean, it's an honest question in one sense, in that I think that as we look ahead as to what is going to happen with agentic AI, this is exactly what we're going to see is time compression, because things are just moving so incredibly fast. Along with that, we get a lot of hype, a lot of, gee, look at how well this works, except when you get into the field, maybe it doesn't work quite so well. So my question to both of you is, what is it going to take to make an AI agent really actually useful and not just flashy, not just pretty, but really honestly helpful? Fabrice, you're looking like you wanted to answer this.
Yeah, I got one word: trust.
Trust.
I think the first step, whatever we build, whether you do it, use software vendors, no, don't do it at home. It's going to take too long. We're here for that. We'll discuss that. But whatever you do, whatever the path you choose, okay, the first point can be trust. Because when you look at people using the systems, usually the first thing they do is ask a simple, naive question. And then they realize the system replies, whether it's a chatbot, whether it's a more sophisticated thing. Then they ask a second question, a bit more refined. And then the third question is something super, super advanced that they imagine only they know the reply to check if the system is good and valid enough. They're trying to trap the system because they need to trust the system. And at some point, the problem is that if you build something that you haven't evaluated enough and you put in front of your customers or your users, whether it's internal, external, whatever, something that rapidly people feel that they can't trust, they will stop using it. And whatever effort you make to build that, you can throw everything to the garbage and it's going to take you years, months, years to come back with something new because people will have this, can't trust the system. So for me, the main hurdle is trust, establishing trust. And the question is, how do you tune, how do you evaluate the system that you built? How do you monitor the capability of your system that's degrading over time so that the trust remains in place for your users?
Yeah. Mary D, can I pile on just a little bit with that too?
Oh, please do.
So there's a couple things that we see, and just to go with what Fabrice said, absolutely trust is the top one. That's why, like I was showing examples, like we were always, anytime we give a result or our assistant gives back a result, there's links to the appropriate documentation. And as a Sinequa employee, I actually use our tools. And if I'm doing development work or something like that on our servers, I'm certainly using our agent to ask questions. And invariably, I'm poking through the links, checking the documentation. There's a certain amount of that has to happen. The other part that we see is you have to implement things slowly. You don't just roll out a chat bot that covers everything that a large organization does. You pick something, you do it focused, you make sure it works right, you make sure people are happy with the results and they're trusting the results, and then you can start to expand that into other teams. But you have to build, as Fabrice said, you have to build trust really, really early in the process. And part of that is just showing, having the agent show its work.
One of the other things that struck me in both of your presentations was how many times you talked about failure. This doesn't usually happen in presentations. People are always talking about successes. But I think it was your very first slide, Jim, where you talked about how you were trying to show your mother something, and here it was, and it was all wrong. And I'm pretty sure that all of us who have tried to use any kind of a chatbot or an LLM on the open web have encountered this. I love the ones that are travel related, where somebody says, well, I'm going to a particular city, tell me what is within walking distance of a particular place. And 9 times out of 10, the answer is just, are you kidding me? I can't get there from here. So the failure piece, I think, is interesting. And I think because this is a nascent technology, there are bound to be failures. So how, in your view, how have organizations truly gone wrong on this? And what can we make sure that they do to make it work well, to basically to get it right?
So what we see is organizations tend to go wrong early on by not thinking about the fact that an LLM is going to produce an answer, and it will try to be very, very friendly, and it may not be using the right information to produce that answer. Like, that's the first thing you have to think about. And then you have to think about, well, how do I get it the information that it needs to work with? And I like to say that a lot of times this is where two IT guys and an LLM get together and they throw a bunch of PDFs into something, and they call it a solution to the problem, and it absolutely isn't. There's a lot of work, if you're going to use our platform, there's a decent amount of work that goes into figuring out how you rank within the search part of our product that both end users and the agent are going to use. So thinking through, how do you decide if something is relevant? How do you use the acronyms? How many variants of the acronyms there are? What kind of synonyms get used? You have to think through how all of that's going to work before you ever start deploying that agent. So you're providing it with useful information right from the start, and you're ranking that. We have a ranking process that actually happens when the agent is asking questions or when I'm asking questions, and we're ranking results. And there's a certain amount of testing you have to do, a certain amount of trial and error to get that right before you start rolling it out. But it goes back to, if you're not doing something early on to think about how you're going to build trust with your end users and then proving it to them, your project is dead in the water. It may take 6 months, but it's dead in the water.
Yeah,
Fabrice, I think you
agree.
mentioned something about
Uh,
complexity.
I fully agree. I think that where companies got it wrong is believing that it's an IT thing, that it's a technological project.
Hmm.
It's not.
Yeah.
It means like that was something new, and probably IT teams and developers were like, "Oh my god, it's so cool! Let's play with that." And then they said, and they said to everyone in the company, "It's for us. You can't do that. It's too technical." Is what I mean. It's like highly complex, and there's a lot of things
Hmm.
to be mastered there. And what we've seen at our customers where there were failings, like IT teams, or they have hired a bunch of developers or these
Hmm.
big consulting companies to do the project. And we really attended to meetings where people say, "Oh, uh, give us all the content that you have." So people were handing over content. And I saw one guy from the tech doc department say, "But you don't need the metadata." And the guy from the IT department says, "What are metadata? What is
Oh,
that?"
Lord.
She was it's a developer. The guy is doing
Okay.
API code, Python code on API. The guy just knows that somewhere there's content needed to be thrown at the LLM. And the guy was really asking that question: what is a metadata? How do you expect? And it's all about content. It's not about the technology. It's about the data. It's about the content. Any AI related project is about content. The technology part is moving so fast that anyway,
Yeah.
whatever this dev
Yeah.
team would take that week, 2 weeks, 3 weeks, 4 weeks after that, they can throw everything and restart the project. See what I mean? So it's not about the technology, but it's all about the content. And this is what most companies, most dev team, most projects have forgotten. It's just about the data.
Yeah. Yeah, just building on that, the person who didn't know what metadata was, we did have a question about is there a role anymore for taxonomies? Because if they don't know
More
what
than
metadata
ever.
is, I will make you a bet they don't know what a taxonomy is either.
I would say more than
Um,
ever, more than before.
yes.
Really? Okay.
Yeah, that was a bit out of fashion. Taxonomy has been a bit out of fashion for me. That was sort of a librarian stuff in the past, like to categorize your content. And then with this keyword search technology and all that, people say, "Oh, we don't need metadata anymore. We put good search technology on top, and we'll find the documents we need." And probably
Hmm.
most companies have gone past text tagging and all that. And I think now with AI, it's like it's coming back full force. It's like, yeah, more than ever.
Yeah.
That's
Jim?
interesting.
Um, I'd like to add a little bit more to that because I think that one popped up during my presentation, probably when I used the word taxonomy.
Probably.
So, because if you trot that word out, somebody's going to respond to it somewhere. So we actually use that in several different
Yep.
places in Sinequa, and you can pull dynamic taxonomies right in. So when I've said things like
Hmm.
keywords or taxonomies, we do something called entity recognition as part of
Hmm.
our indexing process, and that's finding keywords and phrases and flagging those for future use in search or for even highlighting things in results that come back. So we'll use them there. We'll use them to build knowledge graphs. So, and that's something
Ah,
that our agent can actually work with to try to figure out how to answer a question. And then they also get used as somebody's asking a question and that question itself is being processed. Um, as you're getting ready to run the queries or the agent is getting ready to build out its own queries, it's going to be working with that taxonomy too. That's part of the information that it actually has available to it. And yeah, they're actually super important. That's metadata is too, but those things can
yeah.
be super important, especially if you have a well built out one that's got lots of good data in it. Like they can be really helpful.
Well, I'd like to turn the discussion to security because both of you touched on this, and I'd like to know what's your top advice for scaling the AI powered knowledge delivery throughout the entire organization without compromising security or context. And in light of that, we did have a question about what do you do when the knowledge is, it may be internal, but it's not owned by the enterprise. And how does that affect the security and any risk aversion that may be endemic to the enterprise? Um, Jim, let me start with you on that one.
Sure. So I'm going to answer the general security question first, because we run
Okay.
into this all the time.
Yeah.
Especially we work with SharePoint. That's one
Yep.
of the bigger data sources that we work with. There's lots of security in SharePoint. It is complicated at best. And our goal is simply to only produce data for somebody that they have access to. So that's just as we are extracting and indexing data, we're actually talking to the security, pulling security data back, and we're also paying attention to what groups a user belongs to. And then at query time, whether it's the agent or an end user doing the queries, we're going to be respecting that security and making sure you only get answers based on data that you see.
Hmm.
There's an interesting side, and we do that with everything that we work with. So all of the connectors that we use. As an interesting side note, with SharePoint especially, we will frequently stand up the system, get it up and running, people start testing it, and you find all sorts of things that probably shouldn't be exposed
Uh,
that are hidden off in some deep, dark corner of SharePoint somewhere. And it's very much been security through obscurity, and all of a sudden it's not anymore. Um, as for knowledge that we're using, it really comes down to, even if the company doesn't own it, it's how is it licensed and
mhm.
how are you providing access to the end users? And we're just going to keep working with however you have that already
Yep.
configured. Or if you need to
Yep.
rethink it a bit, you can do
Yep.
that too. And then we'll work with whatever you've already thought to. All right.
Fabrice.
Yeah, security, I agree. It's like that's the difference between an in-house development made by developers that forget that when they pull content from everywhere, they need as well to pull the security rules and use that. And that's part of the failure of those projects most of the time,
Yeah.
as opposed to platforms like Fluid Topics and Sinequa, where we do have this security by design in our product. So
Yep.
it's
Yep.
fully,
Yep.
it's there. I mean, you don't even have to think about it. It's there.
Yeah.
I think that's what's interesting now. And if you look at MCP, a big part of the MCP standard recently has been including OAuth, which is the authorization protocol into MCP to make sure that the profile of the user goes through this agentic and dialogue to make sure that it's conveyed as well to the endpoints. So it's there. If you use good products, mature products, it's there, no problem. Now, what's interesting, I like the second question, which is what is about external content?
Yeah.
That's very interesting because we have internally a chatbot that is using MCP only. One is our own knowledge, product knowledge, Fluid Topics. We have one MCP server on our Jira system. So all our, as I've shown previously in my slide, all our main internal systems are MCP enabled. So
Right.
we are just have this chatbot where you can ask any questions like what's ongoing on the dev side? Have we forgotten to document something? And it's checking everything everywhere. But interestingly, we have added to the mix. We are pointing to Wikipedia is MCP enabled as well. So we can point from our internal agent system. We as well reference external data
Right.
sources that are MCP enabled. And you don't have to do anything. It's just declaring Wikipedia, the
Sure.
MCP server endpoint, and say,
Sure.
if you need, and we say to our agent in the configuration, if you need knowledge that is more generic, like about a standard or whatever, then there's Wikipedia, and then the system goes to Wikipedia automatically.
Yeah.
So it goes, and what is interesting, it goes with MCP, it goes both ways. You can build an agentic system that connects to your own knowledge and as well to external knowledge, like pointing to Wikipedia or whatever web search engine. But the other way, you as a company, as a provider, you can build an MCP server that you make available to the rest of the world so that any of your partner or whatever can build an agentic system that is going to query your own MCP server to dynamically pull knowledge about your products. Because what's
Yeah.
interesting is when agentic system that you don't build, that you don't control, that can be built by your subcontractors or by your customers, can as well pull knowledge from knowledge that you make available still with security rules, and then the own agentic system can tap into your own knowledge that you make available to them without giving them the knowledge. You don't have to hand over the documentation anymore. You can just say, if you build an agentic system that needs to know something about our own products, ask there. It's like having a hotline for LLMs. You see what I mean? It's like someone available to reply to LLMs. The same way that you have people replying to humans, you will have to replicate that to talk to LLMs 24/7.
Okay.
We will have to mirror everything. Everything that we were doing for humans, we will have to redo it for agents. So the same way that you have some people replying to questions, you will have MCP servers that you make available to reply to external LLMs.
What an interesting view of the future. Okay. That is all the time we have for questions today, unfortunately. And we apologize we were unable to get to all of your questions. But as I stated earlier, all questions will be answered via email. And I would like to thank our speakers today, Fabrice Lacroix, CEO and founder Fluid Topics, Jim Marlowe, sales engineer Sinequa. If you would like to review this event or send it to a colleague, please use the same URL that you used for today's event. It will be archived for 90 days. Plus, you will receive an email with the URL to view the webinar once the archive is posted. If you would like a PDF of the deck, go to the handout section once the archive is live. And thank you again for joining us.
Thank you. Thank you, Marty.
Thank you, everybody.